The gas mask is a mask used to protect the user from inhaling airborne pollutants and toxic gases. The mask forms a sealed cover over the nose and mouth, but may also cover the eyes and other vulnerable soft tissues of the face. Some gas masks are also respirators, though the word gas mask is often used to refer to military equipment. The user of the gas mask is not protected from gas that the skin can absorb. Most gas mask filters will last around 24 hours in an NBC situation. Airborne toxic materials may be gaseous or particulate. Many gas masks include protection from both types. Gas masks are used in construction to protect against welding fumes, in deconstruction to protect against asbestos or other hazardous particles, and in the chemical industry when handling hazardous materials, as in making repairs to leaking equipment or cleaning up after spills. Workers are usually issued gas masks as a precaution against leaks. During riots where tear gas or CS gas is employed by riot police, gas masks are commonly used by police and rioters alike. Aside from serving their functional purposes, gas masks are also used as emblems in industrial music, by graffiti taggers because the mask protects them from the graffiti canister's toxic fumes, and by urban explorers venturing into environments where hazardous materials, such as asbestos, may be present. The traditional gas mask style with two small circular eye windows originated when the only suitable material for these eye windows was glass or acrylic. As glass is notoriously brittle, glass eye windows had to be kept small and thick. Later, discovery of polycarbonate allowed gas masks with a big full-face window. Some have one or two filters attached to the facepiece. Others have a large filter connected to the facepiece by a hose. Principles of construction: absorption is the process of being drawn into a body, or substrate, and adsorption is the process of deposition upon a surface. This can be used to remove both particulate and gaseous hazards. Although some form of reaction may take place, it is not necessary. The method may work by attractive charges. For example, if the target particles are positively charged, use a negatively charged substrate. Examples of substrates include activated carbon, and zeolites. This effect can be very simple and highly effective, for example using a damp cloth to cover the mouth and nose whilst escaping a fire. While this method can be effective at trapping particulates produced by combustion, it does not filter out harmful gases which may be toxic or which displace the oxygen required for survival. Safety of old gas masks: gas masks have a limited useful lifespan that is related to the absorbent capacity of the filter. Once the filter has been saturated with hazardous chemicals, it ceases to provide protection and the user may be injured. Most gas masks use sealing caps over the air intake to prevent the filter from degrading before use, but the protective abilities also degrade as the filter ages or if it is exposed to moisture and heat. Very old unused gas mask filters from World War II may not be effective at all in protecting the user, and can even potentially cause harm to the user due to long-term changes in the filter chemical composition. World War II gas masks contained blue asbestos in their filters. It is unknown how long for certain the material was used in filters. Breathing blue asbestos in the factories resulted in the death of 10% of the workforce due to pleural and peritoneal mesothelioma. This rate was between 2.5 and 3.2 times the normal incidence of lung or respiratory cancers. Many scare stories have originated from various Russian gas masks and their filters that are now common in surplus stores. The GP5 was often considered to have an asbestos filter. In October 2013, an asbestos lab in Salt Lake City found out that the particle filter is made of 7.5% asbestos. The filter is made so that the asbestos fibers cannot be breathed in, if the filter layer is not damaged. Nearly all Russian Cold War period masks contain asbestos. Modern gas masks are quite safe and do not use asbestos, but it is still important to be careful when using a modern gas mask. Typically, masks using 40 mm connections are more recent design. Rubber degrades with time, so new in-box modern type masks can be cracked and leak. Also, the USC-2 canister was shown to contain hexavalent chromium. The studies by the U.S. Army Chemical Corps showed that the levels in the filter were acceptable, but show caution when using, as it is a carcinogen. Filter classification: the filter is selected according to the toxic compound. Each filter type protects against a particular hazard: AX, low-boiling organic compounds; A, high-boiling organic compounds; B, inorganic gases; E, sulfur dioxide and hydrogen chloride; K, ammonia and amines; CO, carbon monoxide; Hg, mercury, reactor, iodine and methyl iodide; P, particles. Classified as P1, P2, and P3 according to removal efficiency: ABEK, EBOK P3, ABEK HG P3 or other combination filters against multiple hazards. Particle filters are often included, because in many cases, the hazardous materials are in the form of mist, which is captured already by the particle filter before entering the chemical adsorber. Filtration may be aided with an air pump to improve wearer comfort. Filtration of air is only possible if there is sufficient oxygen in the first place. Thus, when handling asphyxiants, or when ventilation is poor or the hazards are unknown, filtration is not possible and air must be supplied from a pressurized bottle as in scuba diving. Also, a gas mask does not protect against other hazards. For example, corrosive gases can damage the skin, requiring full body protection. Use of a mask. A modern mask typically is constructed of an elastic polymer in various sizes. It is fitted with various adjustable straps which may be tightened to secure a good fit. Crucially, it is connected to a filter cartridge near the mouth either directly, or via a flexible hose. Some models contain drinking tubes which may be connected to a water bottle. Corrective lens inserts are also available for users who require them. Masks are typically tested for fit before use. After a mask is fitted, it is often tested by various challenge agents. Isomyl acetate, a synthetic banana flavorant, and camphor are often used as innocuous challenge agents. In the military, tear gases such as CN, CS, and stannic chloride in a chamber may be used to give the users confidence in the efficacy of the mask. Reaction and exchange: this principle relies on substances harmful to humans being usually more reactive than air. This method of separation will use some form of generally reactive substance coating or supported by some solid material. An example is synthetic resins. These can be created with different groups of atoms that have different properties. Thus a resin can be tailored to a particular toxic group. When the reactive substance comes in contact with the resin, it will bond to it, removing it from the airstream. It may also exchange with a less harmful substance at this site. Though it was crude, the hypo helmet was a stopgap measure for British troops in the trenches that offered at least some protection during a gas attack. As the months passed and poison gas was used more often, more sophisticated gas masks were developed and introduced. There are two main difficulties with gas mask design: the user may be exposed to many types of toxic material. Military personnel are especially prone to being exposed to a diverse range of toxic gases. However, if the mask is for a particular use, then the design can be much simpler and the cost lower. The protection will wear off over time. Filters will clog up, substrates for absorption will fill up, and reactive filters will run out of reactive substance. Thus the user only has protection for a limited time, and then he must either replace the filter device in the mask, or use a new mask. History and development of the gas mask. According to Popular Mechanics, the common sponge was used in ancient Greece as a gas mask. An early type of rudimentary gas mask was invented in the 9th century by the Banu Musa brothers in Baghdad, Iraq. They described it in their Book of Ingenious Devices, mainly for protecting workers in polluted wells. Primitive respirator examples were used by miners and introduced by Alexander von Humboldt already in 1799, when he worked as a mining engineer in Prussia. Long before that there was a plague doctor's bird beak-shaped mask face piece filled with herbs. The forerunner to the modern gas mask was invented in 1847 by Louis P. Haslett, a device that contained elements that allowed breathing through a nose and mouthpiece, inhalation of air through a bulb-shaped filter, and a vent to exhale air back into the atmosphere. According to First Facts, It states that the gas mask resembling the modern type was patented by Louis Vectic Haslett of Louisville, Kentucky, who received a patent on June 12, 1849. U.S. Patent 6529 issued to Haslett, described the first inhaler or lung protector that filtered dust from the air. Early versions were constructed by the Scottish chemist John Stenhouse in 1854 and the physicist John Tyndall in the 1870s. Another early design was the safety hood and smoke protector invented by Garrett Morgan in 1912, and patented in 1914. It was a simple device consisting of a cotton hood with two hoses which hung down to the floor, allowing the wearer to breathe the safer air found there. In addition, moist sponges were inserted at the end of the hoses in order to better filter the air. There is a common misconception that safety hood and smoke protector inspired WWI-era gas masks. The density of gases in the WWI theater were heavier than air they were dispersed into. This would mean that the gas would creep along the ground, often filling in the trenches and shell craters below ground level. The use of a device that draws clean air from the floor would facilitate the effect of the gas rather than protect against it. The first use of poison gas on the Western Front was on April 22, 1915, by the Germans at Ypres, against Canadian and French colonial troops. The initial response was to equip troops with cotton mouth pads for protection. Soon afterwards the British added a long cloth which was used to tie chemical-soaked mouth pads into place, and which was called the Black Veil Respirator. Dr. Clawnie Macpherson of Royal Newfoundland Regiment brought the idea of a mask made of chemical-absorbing fabric and which fitted over the entire head to England, and this was developed into the British Hypo helmet of June 1915. This primitive type of mask went through several stages of development before being superseded in 1916 by the canister gas mask of 1916. This had a mask connected to a tin can containing the absorbent materials by a hose. The British Royal Society of Chemistry claims that British scientist Edward Harrison developed the first practical gas mask for mass production, a claim supported by a thank you note written by Winston Churchill. American chemist and inventor James Burt Garner is credited by American sources with the invention of the gas mask in April 1915. Reading a newspaper article describing a gas attack on British forces which he hypothesized had employed chlorine gas, Garner remembered experiments he had performed while teaching at the University of Chicago, thus he set about creating the first gas mask which he tested on two of his associates in a gas-filled chamber. Following the successful completion of the test, he provided the results to the British government. Also in World War I, since dogs were frequently used on the front lines, a special type of gas mask was developed that dogs were trained to wear. Additionally, gas masks were developed during World War I and the time following for horses in the various mounted units that operated near the front lines. In America, thousands of gas masks were produced for American as well as Allied troops. Mine Safety Appliances was a chief producer. This mask was later used widely in industry. The modern gas mask that people in the USA are familiar with today was developed in 1944 by the U.S. Army Chemical Warfare Service. It was made of plastic and rubber-like material that greatly reduced the weight and bulk compared to World War I gas masks and fitted the user's face more snugly and comfortably. The main improvement was replacing the separate filter canister connected with a hose by a filter canister screwed on the side of the gas mask, that could be replaced easily. Also, it had replaceable plastic lenses, much helping vision. Gas masks' development since has mirrored the development of chemical agents in warfare, filling the need to protect against ever more deadly threats, biological weapons, and radioactive dust in the nuclear era. However, where agents that cause harm through contact or penetration of the skin occurs, such as blister agent or nerve agent, a gas mask alone is not sufficient protection, and full protective clothing must be worn in addition, to protect from contact with the atmosphere. For reasons of civil defense and personal protection, individuals often buy gas masks believing that they protect against the harmful effects of an attack with nuclear, biological, or chemical agents. Which is only partially true, as gas masks protect only against respiratory absorption. Whilst most military gas masks are designed to be capable of protection against all NBC agents, they can have filter canisters proof against those agents or only against riot control agents and smoke. Likewise, there are lightweight masks solely for use in riot control agents and not for NBC situations. Although thorough training and the availability of gas masks and other protective equipment can render the casualty-causing effects of an attack by chemical agents nullified, troops who are forced to operate in full protective gear are less efficient in completing their given tasks, tire easily, and may be affected psychologically by the threat of attack by these weapons. During the Cold War era, it was seen as inevitable that there would be a constant NBC threat on the battlefield, and thus troops needed protection in which they could remain fully functional. Thus protective gear, and especially gas masks, have evolved to incorporate innovations in terms of increasing user comfort, and in compatibility with other equipment. The gas mask has thus now arrived at a fourth generation of development. History of absorbents and neutralizers. Activated charcoal is a common component of gas masks. It is a form of carbon with an extremely high surface area which attracts all manner of pollutants from air and water. Pollutants do not react with the carbon but are adsorbed into the pores. Over time the activated carbon becomes thoroughly coated and it ceases to remove pollutants. However, the charcoal can be reactivated and restored to its original state by baking the charcoal with high heat, which evaporates or burns off the pollutants. The first effective filtering activated charcoal gas mask in the world invented in 1915 by Russian chemist Nikolai Zelinsky. In the first gas masks of World War I, it was initially found that wood charcoal was a good absorbent of poison gases. In about 1918, it was found that charcoals made from the shells and seeds of various fruits and nuts such as coconuts, chestnuts, horse chestnuts, and peat stones performed much better than wood charcoal. These waste materials were collected from the public in recycling programs to assist the war effort. See also, GP5 gas mask, M40 field protective mask, NBC suit, respirator, smoke hood. References. External links: Le Masque Gaz International Historical Gas Mask Gallery, with collection of safety and propaganda posters. Gas masks UK. Information on gas masks from many countries. What you should know about gas masks. How stuff works. Gas masks, your gas mask guide to the maintenance of your gas mask. Respirator fact sheet, CBRNS CBA approved respirators. List of NIOSH approved CBRNS CBA respirators. World War I gas mask technology, combating man's deadliest peril. How the unending struggle between gas and mask is carried on. Popular Science Monthly, December 1918, page 64, scanned by Google Books, http://books.google.com/books ID =8 PG PA64, links to images, WWII gas masks with hose and canister, modern gas mask with one big front window.